Hi you guys, welcome back to my channel. Today we're going to be discussing 30, 60, 90 triangles and how to solve them when given one side, and also how to prove that this indeed is a way to solve these triangles. So we're going to start with the proof. So I'm just going to draw another triangle over here. So part of the proof for this triangle is proving that the distance x, which is across from 30, is equal to 1/2 of the hypotenuse. So basically that 1/2 h is equal to x. The way that we can do this is I'm going to extend the triangle out to the left the same distance x. I'm then going to draw this triangle up, so I make one large triangle. This is a right angle. Because these sides are the same, that means this angle also must be 60, and this angle up here must also be 30. So now, if you think about it, right here we have what we can call an equilateral triangle. In an equilateral triangle, all angles are equal and all sides are equal. We know that this is equilateral because if we add the two angles here, which is 30 plus 30, that gives us 60. And then we would have angle 60 here, angle 60 here, and angle 60 here. 3 times 60 equals 180, which means that we do have a real triangle. Now, something else that we know is that angle measurements correspond to the length of sides in a triangle. So if you look here, we have angle 60, and across from it is hypotenuse h. Here we also have angle 60, and across from it is also hypotenuse h. So we know that these two sides are equal, and they're across from equal angles. Here, since we also have an angle of 60, across from it we have x plus x. And we must know that since it's across from an angle that is 60 degrees, and other angles of 60 degrees are across from side h, x plus x is equal to side h. That means we have 2x is equal to h, so x is equal to 1/2 h, which we can prove over here with side A being the side across from 30 and 2a being across from the 90 degrees. The hypotenuse is twice the size of A, which we have written here and here. So Pythagorean Theorem tells us that a squared plus, I'm going to do L for long leg squared, is equal to 2a squared. We simplify this. We're going to add my parentheses here, so we make sure that we square both parts of that. When you simplify this, you get a squared plus L squared is equal to 4a squared, because we have to square the 2 and we also need to square the a. We're going to subtract a squared from both sides in order to get L by itself. I'm going to write the rest to the right. That would give us L squared equals 3a squared. To get rid of these squares, we're going to apply a square root to both sides. Here we have a pair of L's, so that means we can take an L out of the square root. There's nothing left inside, so no more square root. Over here we have 3 and a pair of A's, which means we can take an A out of the square root and we leave the 3 inside. So we get the long leg is equal to a square root of 3. So now we just proved why each of these side lengths are what they are. Now we're going to solve these triangles the same way that we solved 45, 45, 90 triangles. Something important to note here though is that because the sides are different, because we have different angles across from them, you always need to be very conscious of where your 30 degrees is and where your 60 degrees is. So for problem 1, let's say I give the side across from 30 a length of 3, and I want you to find the long leg and the hypotenuse. So just like for our 45, 45, 90 triangles, we're going to set the sides equal to each other that correspond to each other. This might be easier to see if we change the colors of these sides. I'm going to make this side this reddish color, which corresponds to here, right? Because both these sides are across from 30s. I'm going to make this side over here a greenish color, because both of these sides are across from 60s, and the hypotenuse I'll make a bluish color. So now basically set the colored sides that are equivalent equal to each other. So we know that 2a is equal to y, because blue equals blue. We know that a root 3 is equal to x, because green equals green, and we know that a equals 3. So in order to solve this problem, we're going to go to the equation that only has one variable in it, which is this one down here, which is a is equal to 3. So now that we know what a is, we can plug a in for the rest of our equations and figure out what the answers will be. So y, we're going to plug in 2 times 3, because a is equal to 3, which tells us that y is equal to 6. And for x, we're going to plug in 3 times the square root of 3, which tells us that x is equal to 3 root 3. And now we know all of the sides of this triangle. Let's try another one. Let's say I give you that the hypotenuse is 12, and I want you to find side x, and I want you to find side y. So we know that 12 is equal to 2a, because blue equals blue, or hypotenuse equals hypotenuse. We know that x equals a root 3, because they're both the long legs, and we know that y equals a, because they're both the short legs. So we're going to start by solving the equation that only has one variable, which is 12 equals 2a. To get a by itself, we're going to divide both sides by 2, and we're going to get a is equal to 6. So now, in order to find what the other sides are, we're going to plug in for a. So for x, we would plug in a at a root 3, and we're going to get 6 root 3 is equal to x. For y, y is just equal to a, so y is just equal to 6. Let's try another one. Let's say I give you that the long leg is 4 root 3, and I want you to find the length of the hypotenuse and the length of the short leg. So we're going to set up our equations. We know that 2a is equal to x. We know that a root 3 is equal to 4 root 3. And we know that a is equal to y. So we're going to go to our equation that only has one variable in it, which is the middle one, and we're going to solve for a. So a root 3 equals 4 root 3. We're going to divide both sides by the square root of 3 to get a by itself. That square root of 3 is going to cancel each other out, and you get a is equal to 4. Now we're going to plug this into our other equations. X is equal to 2 times a, so 2 times 4, and that's equal to 8. And y is just equal to a, so y is equal to 4. Let's try one that's a little bit harder. What if I didn't give you a side with the square root of 3 in it already, and I just gave you that the long leg is equal to 6? How would you solve this problem? We're going to start by doing what we always do, and set our sides that are equal to each other. So 2a equals x, 6 equals a root 3, and y equals a. We're going to go to our equation that only has one variable in it, which is 6 equals a root 3, and we're going to solve for a. To do that, we're going to divide both sides by the square root of 3. Square root of 3 is going to cancel that over here, and you would get that a is equal to 6 over the square root of 3. But just like with 45, 45, 90 triangles, we don't want to have a square root in the bottom of our formula. So what we need to do is we need to rationalize this equation. The way that we rationalize is we're going to multiply both the top and the bottom by the square root of 3. The reason we're able to do this is because the square root of 3 over the square root of 3 is the same thing as 1. So by multiplying by 1, we're not changing the value of our number. So we're going to end up with 6 root 3 over root 3 times root 3 is 3. 6 divided by 3 is 2, so we get a is equal to 2 root 3. So now we can plug this in to solve for the rest of our problems. We know that x is equal to 2 times a, so x is going to be equal to 2 times 2 root 3. So x is equal to 4 root 3. Y is equal to a, so y is just going to be equal to 2 root 3. Let's try some practice problems now. Let's say I gave you the hypotenuse is equal to 14. Can you find x and can you find y? Pause the video now and come back when you're done. Okay, so we're going to do this problem by setting all sides equal to each other. So 2a equals 14. A root 3 is equal to x. And a is equal to y. We're going to go to our equation that only has one variable in it, which is the first one. We're going to divide both sides by 2 to solve for a, and we're going to get that a equals 7. Now we're going to plug a in to the rest of our formulas, and we're going to get x is equal to 7 root 3, and we're going to get that y is equal to 7. Let's try another one. If I tell you that the short leg is equal to the square root of 3, can you tell me what the long leg is and what the hypotenuse is? Start by setting your equations equal to each other. So 2a equals y. A root 3 is equal to x. And root 3 is equal to a. So we're going to go to our equation that only has one variable in it, which is root 3 is equal to a. We're going to plug that in now for all the other a's. So x is equal to root 3 times the square root of 3. The square root of 3 times the square root of 3 is just 3. Now this is important. Just because a is equal to square root of 3 doesn't mean that you get to prevent plugging it into your long leg. Even though it's still a square root of 3, you still need to plug it in. Otherwise, you're going to get both sides are equal to the square root of 3, and that would be true of 45, 45, 90 triangle, but not of a 30, 60, 90 triangle. Now our long leg is going to, our hypotenuse is going to be equal to 2 times the square root of 3, which is just 2 root 3. Let's do one more practice problem. If I tell you that the long leg is equal to 2 square root of 2, can you tell me what the short leg is, and can you tell me what the hypotenuse is? Start by making our equations. So 2a is equal to y, 2 root 2 is equal to a root 3, and a is equal to x. So we're going to go to our equation with only one variable in it, and we're going to solve for a. So 2 root 2 is equal to a root 3. To get a by itself, we're going to divide both sides by the square root of 3. Here they're going to cancel out, and we get a is equal to 2 square root of 2 divided by the square root of 3. Now we need to rationalize this equation because we don't want to have square roots in the bottom. We multiply both the top and the bottom by the square root of 3. That'll give us on top, we're going to have 2 times root 2 times root 3 over root 3 times root 3 is 3. Now, when we're multiplying square roots, what you can do is multiply the insides of the square roots. So this would turn into 2 times the square root of 2 times 3, which is 6, over 3. So we get that a is equal to 2 square root of 6 over 3. Now we can plug that into our other equations. We know that y is equal to 2a, so y is equal to 2 times 2 root 6 over 3. When you multiply through, that turns into y is equal to 4 root 6 over 3. A, or x, is just equal to a, so x is equal to 2 root 6 over 3. This has been solving 30, 60, 90 triangles.